Today we're going to look at the second chapter, or the second section, chapter 8 I should say. And this is about how do you solve quadratic equations using what's called the quadratic formula. Well, before we get to that formula, we need to do a kind of skill building exercise. A general quadratic equation will look like this. So it's going to be so many x squareds plus or minus so many x's plus or minus some constant term equals 0. This is what I mean when I say the quadratic equation in standard form. We need to make sure that all quadratic equations end up looking like that if they don't already. So you may have a job to rearrange the equation the way it's given so that it now becomes its standard form. So for instance, 3x squared plus 5x plus 7 equals 0 would be an example of a quadratic equation written in its standard form. Now, a will be the coefficient of x squared, so in this case it's 3. b is the coefficient of x, which means the number next to x, positive 5. And c in this case is 7. These are going to be important because this a, this b, and this c are going to be part of this quadratic formula, which will allow us to find typically the two solutions to this quadratic equation. Now, another example could be negative 3x squared plus x plus 2 equals 0. In this case, a would be the coefficient of x squared, negative 3, b would be 1, and c would be 2. And that would be the values that we would use in our formula once we get to see what that formula is. If a quadratic equation only has two terms, as long as it has an x squared term, it will be a quadratic equation. In this case, we have that. A is the number next to the x squared. We call that the coefficient of x squared. B is the number next to the x's. We call that the coefficient of x. And there is no plus or minus number. There is no constant term. If something is missing, not there. The value of that particular variable will be 0. And lastly, you could have 2x squared take away 7 equals 0. And in this case, the quadratic equation would be a equals 2. There are no x terms, so b will be 0. And finally, c will be negative 7. So what I'd like and hope that you've got from this is that all quadratic equations need to be written in their standard form first. Once they're written in this standard form, you should be able to identify the values of a, b, and c, whether terms are missing or all three terms are there. So let's assume that we have a quadratic equation and we would like to solve it. For instance, I have x squared plus 4x take away 12 equals 0. And I would like to solve it using the quadratic formula. And here we go then. The solution to the quadratic equation ax squared plus bx plus c equals 0 is given by this formula, which is called the quadratic formula. It's x equals negative b plus or minus the square root of b squared take away 4ac all over 2a. So this is essentially the guy we're going to be using in this section, the quadratic formula. This plus minus part next to the square root is what's typically going to generate you two solutions. The only time you'll get one solution would be when this entire thing is 0. Now, let's take this example here. So I want to solve this guy. Now, what makes this formula so powerful is that if the solutions are nice numbers, you could always get the answer by factoring, but not all quadratic equations can be factored. This equation will get you the answer even when these cannot be factored. It will allow you to get exact values for the solutions. So here is the order that you would approach such questions. Step one is, if needed, you might not need it, is rearrange your equation, your quadratic equation, into standard form. Well, in this particular question, it's already done. Remember, when an equation is written in its standard form, it's so many x squareds plus or minus so many x's plus or minus a number equals 0. So that's step one, kind of already done, so we didn't need to do it. Step two is identify the values, I should say, of A, B, and C. Now, A is the number of x squareds, B is the number of x's, and C is the constant term. So in this particular situation, A is 1 because you have 1 x squared, B is 4 because you have 4 x's, and C is -12. Now, step 3 would be to plug A, B, and C into this formula here. And that certainly could be done in one go. But it's such an ugly equation and it's got so many moving parts to it that if you try to do it in one go, there is a good chance you might screw it up somewhere and not get the result. So what I tend to do is I tend to take this calculation and I break into pieces. The first piece that I get the value for is the bit that's inside the square root. The discriminant, it's called. So in this case, it's going to be 4 squared, take away 4 times 1 times -12. So that's going to be 16, add 48, and that gets me 64. Now, once I have found the value of this, I would then proceed to do the equation, right? Complete the whole process. So here is the formula that we're going to use. So it's going to be the negative of this guy, -4, plus or minus the square root of this guy, all divided by 2 times A, which is 2. Now, since you are going to be typically going to get 2 solutions, what we would want to do is to separate this formula into its 2 pieces. So the first one you would get is -4, take away the square root of 64, which is 8, all divided by 2. And the second solution is going to be x, still -4, but add the square root of 64, which is 8, all over 2. So you see you've got the plus and the minus here. Now, if you combine the top 2 and then divide it by 2, you get the answer -6. So there's one of our solutions. And if you combine these 2, you get 4, which you then divide by 2, and that gets you equals 2, and that is your second answer. And you would normally then write your answer in Weber sign as 2 numbers, comma separated list just means the first number, comma, the second answer. Small comma big would be the way to do it. Now I could check that this works. In other words, I could check that x equals -6 solves this, and I could check x equals 2 solves this. Normally I wouldn't do that because it requires a lot of time. Secondly, WebAssign will tell you if you've got it right, but let's show you how a check works. If you want to check x equals 2, you essentially put it into here, the original equation, before you did anything to it, which is that. You then replace the x by 2, so it's 2 squared, 4 lots of 2, take away 12. That's 4 plus 8, take away 12. And yep, that equals 0. Check. We know it's the solution. We are good to go. And it's essentially the process of using the quadratic equation. Try this process on a homework question. This is question 2. The variables are not x, but that really doesn't matter. The variable happens to be v. So first stage is to rearrange this to its standard form. So I'm going to add 4v to both sides. I'm going to subtract 12 from both sides. And there we go, standard form. A will be 1, B will be that messy 4, and C will be negative 12. So I will now proceed to use the quadratic formula, which I think I'll basically just write it over here. So it's negative b plus or minus the square root of b squared take away 4ac all over 2a. And that's our quadratic formula. So what do we have? We have, instead of x equals, it's just going to be called v equals negative b plus or minus the square root of b squared take away 4ac all divided by twice a. So at the side, I would find b squared minus 4ac. So let me do a little bubble up here, show you what my working would look like. B squared take away 4ac. It's going to be 4 squared take away 4 times 1 times negative 12. That becomes 16 plus 48, which is 64. So I'm going to have, this is kind of deja vu, we're going to have negative 4 plus or minus the square root of 64, all divided by 2 times 1, which is 2. Now separating to its 2 solutions. So first one is going to be negative 4 plus, take away the square root, which is that guy. Looks like we're going to get the same answer as the previous question. Sheer coincidence, of course. So negative 4, add the square root of 64, which is 8 divided by 2. This guy is negative 12 over 2, which gives you one of your solutions, negative 6. And this one is 4 over 2, which, as I said, is by sheer coincidence the same answer as the one that we did. Let's try a really ugly one then. This is question 3, or at least one similar to it. 32t squared equals 20t plus 3. Now I need to get it into its standard form. So I'm going to subtract 20t from both sides and subtract 3 from both sides. Now we have standard form. I'll identify that a is 32, that b is negative 20, and that c is negative 3. And I will be using this formula, but this time I'm going to do this guy first. So it's going to be negative 20 squared, take away 4 times 32 times negative 3. Now, whenever you get something that is really ugly and obviously needs a calculator, let's start. I'm going to do a bracket. Negative is this button down here, negative 20. Close the brackets and press squared. So that's that bit done. Now you subtract, and 4 times 32 times negative 3. And when you hit enter, we get 784. Now the quadratic formula is this guy. And in this case, the variable is t. So t is going to equal negative b plus or minus the square root of b squared take away 4ac all over 2a. Negative of negative 20 is positive 20, plus or minus the square root of 784 divided by 2 times 32, which I believe is 64. So let's see what our two solutions are going to look like. T equals 20, take away the square root of 784. So I'm going to hope that the square root of 784 is a nice number. And guess what it is? It's 28. And the other solution is going to be 20 plus the square root of 784 all over 64. Now, if you take this guy, you would get negative 8 over 64, which simplifies down to negative 1/8. So there's one of your solutions. If t is negative 1/8, it will solve this equation. And in this case here, you're going to get 48 over 64. Not the prettiest answer in the world. I believe it's 3/4. Let's check it out. 48 divided by 64. And then hit the math button, choice 1. And the answer I got was 3/4. So you can see we have two solutions and they work. We'll assume they work. I know they do. Now, up to this point, the answers that we got were exact values, right? There were 2, there were negative 4, there were 3/4, there were negative 1/8. The quadratic formula is much more versatile than that, because what it also allows us to do is it allows us to find solutions to quadratic equations which are not exact in the sense they are real numbers, but they contain square roots in them, like square root of 7s and things like that. And that is something you certainly couldn't do by any other means. So here is the one we're going to do, question 4. It's already in its standard form, so I can tell you A is 1, B is negative 2, and so is C. It's negative 2. I'm going to just do my usual small piece of the formula, which is that guy. And it's going to be negative 2 squared, take away 4 times 1 times negative 2. You can do that one. Is 4 plus 8, and we get 12. So our solution now is going to be V equals negative B plus or minus the square root of B squared take away 4AC all over 2. The negative of negative 2 is 2 plus or minus the square root of 12 divided by 2 times A, which is 2. And now we can split them into two distinct solutions. The first one is that guy. And the second one is that guy. But that's not the best version of that answer. It's correct, but it's not simplified. So we're going to have to work a little bit harder to make this nicer. And the first thing I've noticed, hopefully you did as well, is that the square root of 12 can be simplified. And if it can, you should. So it's going to be 4 times 3. So that's the square root of 4 times the square root of 3, which ends up being 2 root 3. So we now have 2 take away 2 root 3 over 2, and the other answer is 2 plus 2 root 3 over 2. Now that's nicer, but we can do a little bit more. It's not uncommon that in the last part of the process that you take this fraction with 2 pieces on the top divided by 2 and you rewrite it as 2 over 2 take away 2 root 3 over 2. In other words, you separate it into 2 pieces. Now when you do that, this guy becomes 1. They cancel and you get this one. So 1 minus the square root of 3 is our simplified version of one of the 2 solutions. Now a similar thing's going to happen over here. It's going to be 2 over 2 plus 2 root 3 over 2. Those guys cancel and you get 1. Those guys cancel and you get root 3. And so you get 1 plus square root of 3. And now we have our 2 solutions. And you would write them down, that guy, just this bit here, comma, that guy. And that would be your comma separated list that they are talking about. So you see, we're already getting into more and more awkward situations, right? Ones that you have to do a little bit extra work before you're finished. Mostly simplifying your answer so it looks good. So this one is a version of question 6. And if you subtract 12v from both sides and add 21 to both sides, you get that. Now it's in standard form. A is 1, B is negative 12, C is 21. Now I'm going to find the B squared, take away 4ac part, right? Just this piece of the formula. So it's going to be negative 12 squared, take away 4 times 1 times 21. If you want to see that on the calculator, put a bracket around it, the negative button, which is down here, negative 12, close the brackets, squared. Subtract 4 times 1 times 21, and the answer I got here is 60. Our quadratic formula then, V is going to be negative B plus or minus the square root of B squared, take away 4ac, all divided by 2a. It's going to be the negative of negative 12, which is 12, plus or minus the square root of that term, 60, and all divided by 2 times 1, which is 2. And once we get to this, pretty much as you'd expect, we separate it into its 2 distinct solutions. 12 take away square root of 60 over 2, 12 plus the square root of 60 over 2. And we should then think about simplifying the square roots. If it's possible, you might get a square root like the square root of 17. If that happens, then you're fine, you can't really do much that way. But you should try, if it's possible, to simplify it. So here's my little bubble. And if I look at the square root of 60, I should be able to get that into some kind of format. So let's see, I can do 4, that's good. Can I do anything better than 4? let's see, I can go 2, 4, 9, 16, 25, 36. Can't do anything with that. I know that doesn't work. That doesn't work. I don't think it works with 60 and 16, but let's just do it in case it does. 60 divided by 16. Okay, then looks like all I'm going to get is 4 times 15, which becomes the square root of 4 times the square root of 15. So 2 square roots of 15. So this guy is 12 take away 2 square root of 15s. And this guy is going to be 12 add 2 square root of 15s over 2. Have you noticed that the two answers are very similar? So if you get the answer to this, you should be able to make a pretty good prediction what this one is going to look like when it is simplified. So what I'm going to do now is split them into 2 distinct fractions. And then 12 divided by that gets me 6, and that cancels out. I get square root of 15. And I bet you the other one is always going to be the same start number, but with an add. So you can save yourself a little bit of time if you recognize that pattern. There's our 2 solutions. 6 take away the square root of 15, and 6 add the square root of 15. Let's do one more of that type, and then we'll show you something a little bit different, a little bit unusual. So 4v squared, 8v, take away 2. If you subtract an 8v from both sides and you add a 2 to both sides, you get that. So a will be 4, b will be negative 8, and c will be 2. And I will do this guy. So negative 8 squared, take away 4 times 4 times 2. Let's check it. Bracket negative 8, close the bracket, squared, subtract 4 times 4 times 2, and the answer I get is 32. So this piece here inside the square root is going to be 32. So our solutions are going to be negative b plus or minus the square root of b squared take away 4ac all over 2a. The negative of this is plus 8. Add or subtract the square root 32. 2 times a becomes 2 times 4 over 8. That's going to split to 2 distinct solutions. 8 take away the square root of 32 over 8, and 8 add square root of 32 over 8. And I'm going to do the little shortcut. I'm just going to simplify this answer, and then I should be able to predict what the other one looks like. And I just noticed something. So here's my little bubble working. The square root of 32 can be simplified. It's 16 times 2. So it's the square root of 16 times the square root of 2. That ends up being 4 root 2. So we are going to have 8 take away 4 root 2 all over 8. And we'll split it into 2 distinct fractions, both over 8. And 8 divided by 8 is 1, and that partially cancels and gets you root 2 over 2, or if you prefer, a half root 2. It's the same thing. And the second solution then will be the same 2 guys, but with an add. And there is our 2 solutions. So we've been able to use this quadratic formula to solve equations where the numbers are nice numbers like 4 and negative 2. slightly uglier numbers like 3/4 and 5/8. And now we've been able to get exact values to the solution where the answers contain square roots of some kind. So the next question we're going to deal with is the weirdest one of them all. We are going to solve quadratic equations where the answer is a complex number. Yep. So an example of that would be question 9. And it's going to be z squared plus 4z plus 8 equals 0. It's already in its standard form, so A is 1, B is 4, and C is 8. Now, if you calculate the B squared, take away 4AC, you're going to have 4 squared, take away 4 times 1 times 8, which ends up being negative 16. So nothing looks different yet, except that negative 16 does look a little bit weird. And let's see why we end up with complex numbers then. Here is our quadratic equation. The negative of that is negative 4 plus or minus the square root of negative 16, all divided by 2 times 1 is 2. Now we're going to split it into its 2 distinct pieces. And I'm going to do the shortcut. I'm just going to get one answer and then I can predict the other. So I know z is going to be negative 4, take away the square root of negative 16 all over 2. And no, you are not allowed to say that guy and that guy cancel out and the whole thing's just a square root of 16. That is not correct. It doesn't work. So it'd be nice if it did, but it doesn't. However, I do know that this square root is a complex number. And so this is what it would look like. The square root of negative 16 is the square root of 16 times negative 1. We've done that in the past. That splits as the square root of 16 times the square root of negative 1. That guy gets you 4, and this guy we call I. So we now have negative 4 subtract 4I all over 2. That becomes negative 4 over 2 and negative 4I over 2. They cancel and you get 2, they cancel and you get 2. So you're going to get a negative 2 take away 2I. And the other one I can make a prediction. It's going to have the same first number, but a plus 2I. There is your 2 solutions. Yet you get a complex number. And that is us finished. Hopefully this has been of use to you. And bye-bye for now.